What if somewhere in the silent depths of space, a distant planet quietly circles its star, carrying familiar signs of oceans, clouds, and seasons that strangely resemble the world we call home? Astronomers around the world are now focusing powerful telescopes toward a mysterious Earth-like planet that has begun attracting extraordinary attention from scientists searching for clues about life beyond Earth. This distant world, located light years away from our solar system, shows characteristics that appear surprisingly similar to Earth, making researchers curious about whether it might support water, atmosphere, or even simple forms of life. The discovery did not happen overnight, but rather through years of patient observation, careful analysis, and advanced technology designed to detect tiny changes in distant stars caused by orbiting planets. Scientists first noticed subtle patterns in the star's brightness, patterns that repeated regularly, suggesting that a planet might be passing in front of the star during its long journey through space. When astronomers studied the data more closely, they realized the planet's size seemed remarkably close to Earth's, immediately making it one of the most interesting discoveries in recent astronomical research. Size alone does not guarantee similarity, but being close to Earth's dimensions increases the possibility that the planet might have a rocky surface rather than thick layers of gas. Even more exciting was the planet's position around its star, located within a region scientists often call the habitable zone, where temperatures could allow liquid water to exist. Liquid water is considered one of the most important ingredients for life as we understand it, which is why this discovery quickly sparked curiosity across the global scientific community. Researchers from several space agencies began sharing data, comparing observations, and discussing whether this distant world could provide new insights about how planets like Earth form and evolve. Powerful observatories on Earth joined forces with advanced space telescopes, creating a network of instruments designed to gather every possible detail about this intriguing planetary system. By examining the faint light passing through the planet's atmosphere during transit, scientists hope to identify chemical signatures that reveal what gases might surround this mysterious world. Certain gases, such as oxygen, methane, or water vapor, could indicate interesting atmospheric processes, although researchers remain careful and cautious when interpreting such distant signals. The planet's star also plays an important role because the energy and radiation it emits directly influence the planet's climate, temperature, and long-term environmental stability. Early observations suggest the host star is smaller and cooler than our Sun, which means the planet must orbit closer to maintain temperatures that could allow liquid water. This type of star, often called a red dwarf, is extremely common in the galaxy, making planets around such stars valuable targets for scientists studying potentially habitable worlds. However, red dwarf stars can sometimes produce strong stellar activity, including powerful flares that might affect a nearby planet's atmosphere over long periods of time. Because of this possibility, astronomers are carefully monitoring the star's behavior to understand whether the planet could realistically maintain stable conditions on its surface. The planet completes a full orbit around its star much faster than Earth completes a year, meaning scientists can observe many planetary transits within a relatively short period. Each transit provides another opportunity to gather small but valuable pieces of information about the planet's atmosphere, temperature, and overall structure. Advanced computer models are now helping researchers simulate what the planet might look like under different atmospheric conditions and surface environments. Some models suggest the world could contain large oceans covering wide regions of the surface, while others imagine continents, clouds, and complex weather patterns. At the moment, these ideas remain scientific possibilities rather than confirmed facts. Yet they help guide researchers toward new observations and questions. The excitement surrounding this discovery is not only about one planet, but about what it represents in the broader search for Earth-like environments across the galaxy. For decades, scientists wondered whether planets similar to Earth were rare exceptions or common outcomes of planetary formation throughout the universe. Discoveries made during the past few years increasingly suggest that rocky planets within habitable zones might be far more common than once believed. This possibility has encouraged astronomers to expand their search programs, scanning thousands of nearby stars for subtle signals indicating the presence of orbiting planets. As scientists continue observing this distant Earth-like planet, new data slowly emerges, revealing subtle details about its orbit, atmosphere, and environment that deepen curiosity across the global astronomical community. Every passing week brings additional measurements from telescopes on Earth and in space, allowing researchers to refine their understanding of this mysterious world orbiting quietly around its distant star. One of the most important questions scientists ask is whether the planet's temperature might allow water to remain liquid on the surface for long periods of time. Temperature on a planet depends on many factors, including distance from its star, atmospheric thickness, surface composition, and the amount of energy reflected back into space. Researchers carefully analyze how much light the planet receives from its star and how that energy might interact with potential atmospheric gases surrounding the world. Early simulations suggest that if the atmosphere contains the right balance of gases, the planet could maintain temperatures that are neither extremely hot nor permanently frozen. This balance is often described as climate stability, an important condition that allows environments to remain relatively steady over long geological timescales. Earth's climate has remained stable for billions of years due to complex interactions between oceans, atmosphere, geological activity, and solar energy. Scientists are now wondering whether similar balancing processes might exist on this newly studied planet far beyond our solar system. One intriguing possibility involves the presence of clouds that could reflect a portion of incoming starlight, preventing the planet from becoming excessively warm. Clouds also play a crucial role in regulating temperature by trapping heat during colder periods and releasing energy slowly over time. If such cloud systems exist on this distant planet, they could help maintain a balanced climate capable of supporting liquid water environments. Observing clouds from such great distances remains extremely difficult, yet scientists search for indirect signals hidden within the planet's atmospheric data. Certain patterns in reflected light may hint at cloud layers moving across the atmosphere as the planet rotates around its axis. Rotation itself is another important factor because it influences day and night cycles that affect temperature distribution across a planet's surface. If the planet rotates too slowly, one side might remain extremely hot, while the other becomes much colder, creating harsh environmental conditions. However, moderate rotation can help distribute heat more evenly across the planet, creating more stable and balanced climates. Astronomers are currently studying subtle variations in light to estimate how quickly this planet might spin while orbiting its star. Although these measurements remain challenging, even small clues help scientists improve their models of the planet's potential environment. Another fascinating possibility involves the presence of oceans, which play a major role in stabilizing temperatures on Earth. Large bodies of water absorb heat during warmer periods and slowly release it during cooler times, reducing extreme climate fluctuations. Oceans also help transport nutrients and energy across the planet through currents that connect distant regions of the surface. If this distant planet possesses vast oceans, they might contribute to a dynamic and stable planetary system capable of supporting complex chemical processes. Scientists cannot directly see these oceans yet, but certain atmospheric signals could indirectly reveal whether large quantities of water exist. Water vapor, for example, sometimes leaves faint signatures in starlight passing through a planet's atmosphere during transit events. By analyzing these signatures carefully, researchers hope to determine whether water molecules may be present in the upper layers of the atmosphere. Detecting water vapor would not confirm oceans immediately, but it would significantly increase interest in the planet's environmental possibilities. Meanwhile, scientists are also studying the planet's density to understand more about its internal structure. Density calculations suggest whether the planet contains a solid rocky core, similar to Earth, or whether lighter materials dominate its composition. Current estimates indicate that this world may indeed be a rocky planet rather than a gas giant, strengthening its classification as Earth-like. A rocky surface increases the likelihood of geological activity such as volcanic processes, tectonic movement, or mineral cycles. On Earth, these geological processes play essential roles in maintaining atmospheric balance and recycling important chemical elements. Volcanoes release gases that contribute to the atmosphere, while tectonic movements reshape continents and influence ocean circulation. Scientists are now WOW. As observations continue, scientists begin noticing subtle patterns in the planet's atmosphere, patterns that suggest dynamic processes may be shaping its environment in ways surprisingly familiar to planetary scientists. These patterns appear in the faint fingerprints of light captured by telescopes, where tiny variations reveal clues about gases drifting through the upper layers of the planet's atmosphere. Interpreting such signals requires extreme precision because the light reaching Earth has traveled across immense distances before finally entering sensitive scientific instruments. Even the smallest distortion in that light can contain information about temperature, atmospheric pressure, and the chemical composition surrounding the distant world. Researchers carefully examine these variations using powerful computer models designed to simulate planetary atmospheres under many different conditions. These models allow scientists to compare real observations with theoretical environments, gradually narrowing down which atmospheric combinations might realistically exist on this planet. Some early simulations suggest the atmosphere could contain a mixture of gases capable of maintaining moderate surface temperatures under certain conditions. However, scientists remain cautious, emphasizing that interpreting atmospheric signals from distant planets is an extremely complex scientific challenge. One particularly interesting question involves whether the planet might experience weather systems similar to those on Earth. Weather requires interactions between sunlight, atmospheric circulation, and surface conditions that drive winds, clouds, and temperature changes. If the planet possesses a thick enough atmosphere, strong wind systems could distribute heat between the illuminated and darker regions of the world. Such circulation could prevent dramatic temperature differences, allowing the planet to maintain relatively stable environmental conditions. Researchers also investigate whether seasonal changes might occur as the planet travels through its orbit around the star. Seasonal cycles often arise when a planet's axis tilts slightly, causing different regions to receive varying amounts of starlight during different parts of the year. Earth's seasons influence ecosystems, weather patterns, and ocean circulation, creating dynamic environmental cycles that shape the planet's climate. Determining whether this distant planet has a similar axial tilt remains difficult, but scientists are exploring indirect clues hidden within its observational data. Some brightness variations detected during planetary rotations may hint at surface features reflecting light differently as the planet spins. For example, continents, oceans, deserts, or cloud systems could all reflect light in slightly different ways. Although these signals remain extremely faint, advanced instruments can sometimes detect repeating patterns that reveal a planet's rotational characteristics. Another question attracting scientific attention is whether the planet might possess polar regions covered by ice or frozen materials. Ice deposits can reflect large amounts of starlight, influencing the overall brightness detected during specific phases of the planet's orbit. Studying these brightness changes carefully may help scientists estimate how reflective the planet's surface might be. Surface reflectivity, often called albedo, plays an important role in controlling planetary temperatures. Highly reflective surfaces send much of the incoming energy back into space, while darker surfaces absorb more energy and warm more quickly. Understanding the planet's albedo could therefore provide valuable insights into its climate system and environmental balance. In addition to studying the planet itself, researchers also examine the surrounding space environment of the planetary system. Dust particles, small asteroids, or additional planets may influence the long-term stability of the system's orbital dynamics. Detecting other planets nearby could reveal whether gravitational interactions are affecting the orbit of the Earth-like planet under observation. Multiple planets often exist within the same star system, sometimes forming complex gravitational relationships over millions of years. These interactions can alter planetary orbits, occasionally pushing worlds closer to or farther from their stars. Understanding these gravitational relationships helps scientists evaluate whether a planet's orbit has remained stable for long geological timescales. Stability is important because life, if it exists, generally requires relatively consistent environmental conditions over very long periods. If a planet's orbit shifts dramatically, its climate could change rapidly, making stable environments difficult to maintain. Fortunately, early measurements suggest that this planet follows a relatively consistent orbital path around its star. A stable? As research continues, the scientific community grows increasingly fascinated by the possibility that this distant Earth-like planet could reveal important clues about how common potentially habitable worlds truly are. For decades, astronomers wondered whether Earth was a rare cosmic exception, or simply one example among countless similar planets scattered throughout the galaxy. The discovery of this planet has added powerful motivation for scientists to search even more carefully for worlds that share characteristics with our own. Modern astronomical technology now allows researchers to observe distant planetary systems with extraordinary sensitivity compared to instruments available only a few decades ago. Space telescopes equipped with advanced spectrometers can analyze extremely faint signals hidden within starlight that passes through a planet's atmosphere during transit. These signals reveal chemical fingerprints that may indicate the presence of gases formed through natural geological or atmospheric processes. Scientists study these fingerprints carefully, comparing them with known chemical reactions that occur on Earth and other planets within our solar system. However, interpreting atmospheric chemistry requires caution because many gases can form through several different natural mechanisms. For this reason, researchers analyze combinations of gases rather than relying on a single atmospheric signal to understand a planet's environment. Certain gas combinations could suggest interesting environmental interactions occurring within the planet's atmosphere or surface layers. The goal of this research is not to make quick conclusions, but rather to gradually build reliable scientific understanding based on consistent observational evidence. Because of the planet's favorable orbit, astronomers have multiple opportunities each year to observe the planet passing in front of its star. Each transit event provides another chance to gather atmospheric data using powerful instruments both in space and on Earth. Over time, repeated observations improve measurement accuracy and help eliminate uncertainties that appear in early data. Researchers often combine observations from several telescopes to create a more detailed picture of the planet's atmospheric composition. This collaborative approach allows scientists to cross-check results and confirm that signals truly originate from the planet, rather than from background noise or measurement limitations. Meanwhile, planetary scientists continue developing new climate models that simulate how Earth-sized planets behave under different atmospheric conditions. These models explore possibilities such as thick cloud layers, deep oceans, dry rocky surfaces, or combinations of several environmental features. By comparing simulated environments with real observational data, scientists can narrow down which scenarios appear most realistic for this particular planet. Some simulations suggest that even small differences in atmospheric pressure could dramatically influence the planet's temperature and weather patterns. Higher atmospheric pressure could trap more heat, while a thinner atmosphere might allow heat to escape rapidly into space. These delicate balances highlight how complex planetary climates can be, even for worlds that appear similar to Earth in size and orbit. Scientists also examine whether the planet might possess a protective ozone-like layer that could shield the surface from intense ultraviolet radiation. Such protective layers help stabilize environments by limiting harmful radiation reaching lower atmospheric levels. Understanding these protective mechanisms is important when evaluating whether a planet's environment might remain stable over long periods. The presence of a magnetic field is another factor scientists continue investigating through indirect observational clues. Magnetic fields form deep inside planets when molten materials circulate within their interiors, generating protective magnetic shields. Earth's magnetic field protects the atmosphere from energetic particles emitted by the sun. Without this protection, solar particles could slowly erode atmospheric gases, gradually thinning the atmosphere over millions of years. Although detecting magnetic fields on distant planets is extremely difficult, researchers are exploring innovative techniques that might reveal indirect signs of magnetic activity. For example, interactions between stellar wind and planetary magnetospheres may produce subtle signals detectable through specialized observations. While these techniques remain experimental, they demonstrate how creative scientific methods continue expanding the boundaries of planetary exploration. The more scientists learn about this Earth-like planet, the more questions arise about the diversity of planetary systems throughout the galaxy. Observations of distant stars suggest that planets form around many different. As the investigation of this distant Earth-like planet continues, scientists find themselves standing at the edge of one of humanity's most fascinating scientific journeys. Every new observation brings subtle clues about a world that exists far beyond our solar system, yet shares intriguing similarities with the planet we call home. The planet remains only a faint signal hidden within starlight, yet the information carried in that light reveals remarkable details about its environment. Through years of careful observation, astronomers have slowly transformed a distant point of light into a scientific mystery filled with possibilities and unanswered questions. One of the most powerful aspects of this research is how it combines technology, patience, and curiosity to explore places humans may never physically reach. Telescopes orbiting Earth and powerful observatories on the ground continue working together to gather increasingly detailed measurements from this distant planetary system. Each dataset helps refine models that describe how the planet's atmosphere behaves and how energy from its star influences environmental conditions. Researchers analyze temperature estimates, atmospheric signals, and orbital dynamics to understand whether the planet's environment might remain stable over long periods. Stability is essential because complex planetary environments require long timescales to develop balanced climates and active chemical cycles. Even small variations in atmospheric composition can influence how heat circulates around the planet's surface and through its upper atmosphere. Scientists carefully examine these variations to understand whether the planet's climate might support interesting environmental processes. At the same time, researchers continue searching for subtle chemical signatures that could reveal interactions between the planet's surface and atmosphere. Such interactions often shape planetary climates by recycling gases and redistributing energy throughout the environment. Earth itself maintains balance through complex interactions involving oceans, atmosphere, geological activity, and solar energy. Discovering similar processes on another world would provide valuable insight into how planetary environments develop throughout the universe. Although the planet is extremely far away, modern science allows astronomers to investigate its characteristics using remarkably precise instruments. Advances in telescope design, sensor technology, and computer modeling have transformed exoplanet research into one of the fastest-growing areas of astronomy. Only a few decades ago, scientists had not yet confirmed the existence of planets around many distant stars. Today, thousands of exoplanets have been discovered, revealing a galaxy filled with diverse planetary systems. Some of these planets are enormous gas giants, while others are small rocky worlds that resemble Earth in size and composition. Among all these discoveries, Earth-sized planets within habitable zones remain especially important to scientists studying planetary environments. The planet currently under close observation fits many of these interesting criteria, which explains why astronomers continue watching it carefully. Future telescopes now being developed will have the ability to examine exoplanet atmospheres with even greater precision. These instruments may detect extremely faint chemical signals that current telescopes cannot yet measure accurately. With improved sensitivity, scientists may identify atmospheric components that reveal more about the planet's climate system. Some researchers also hope that future missions will be capable of directly imaging distant Earth-sized planets. Direct imaging would allow astronomers to observe the light reflected from a planet's surface and atmosphere without relying entirely on transit measurements. Such observations could potentially reveal cloud patterns, seasonal changes, or surface reflectivity variations across the planet. Although these technologies are still developing, they represent the next major step in humanity's exploration of distant worlds. In addition to studying this planet individually, scientists compare it with many other exoplanets discovered across the galaxy. This comparative approach helps researchers identify patterns that explain how planetary systems evolve over time. By examining hundreds or thousands of planets, scientists can begin identifying which environments appear most common in our galaxy. These discoveries gradually answer one of the most profound questions humanity has ever asked about the universe. That question is whether Earth-like environments might exist elsewhere among the countless stars scattered across the cosmos. Each promising discovery suggests that planets similar to Earth may not be as rare as once believed. If rocky planets frequently form within habitable zones, the universe could contain many environments.